Hey, it's really great to be here. I hope your HashiConf is off to a good start. My name is Mike Nomitch. I'm a product manager here at HashiCorp. And I'm excited to talk to you today because I get to talk about my favorite product that we make, and that is, of course, Nomad. And over the course of this talk, I'm going to be talking about what we've delivered recently on Nomad and Nomad 1.3, some of the things that are coming in the future. And maybe more importantly, I want to talk about why. Why are we building the things that we're building, and what are we driving towards on the Nomad team? And if I had to sum that up in one little pithy statement, I would say we're trying to build a simpler Nomad, and we're trying to do that across multiple facets of the product. And so I'm really excited to get into that. But before I get into what's coming soon and why we're building that, I want to talk about what is Nomad for anyone in here who's not familiar with it, and why do people choose Nomad? And so if you're not familiar with Nomad, it's a scheduler or an orchestrator. So if you know tools like Kubernetes or Docker Swarm or Mesos, it's in that same class of tool. So a lot of the general ideas from those are applicable to Nomad as well. But we think that Nomad has several advantages and reasons why it's unique and why people would try them, or why people come to Nomad and really love it, as opposed to using one of these other tools. And I like to break this down into kind of three categories. And I'll go into this briefly. So the first is flexibility. And Nomad is flexible in kind of all sorts of ways, but I just want to point to two ways in which this flexibility shows through. So first of all, where Nomad runs. So you could, of course, run Nomad on Linux, but you could also run it on a Windows machine, on Mac OS, and our users actually get it running on all sorts of operating systems, BSDs, one of the fun ones that people have it running on. So Nomad is flexible in terms of where it runs. So if you have a mixed-use cluster, if your devs are on Mac OS, it's really nice to just be able to run plain old Nomad on that machine. But Nomad also is flexible in terms of what it runs. And so a lot of the other tools are kind of fashion themselves as container orchestrators. And we tend not to use that term on Nomad because it's so much more than a container orchestrator. So of course, you can orchestrate Docker containers. But you could also give Nomad, a Java jar, and it knows how to run that. You could give it a virtual machine using the QEMU driver, and it knows how to run that. And my favorite is just Nomad knows how to run raw binaries and executables. So say you compile a Go binary, hand it off to Nomad. Nomad's able to run it in isolation in its own network namespace, its own C group, acting somewhat like a container, but all you've done is hand it a raw binary. So there's a ton of flexibility there. And this is an extensible system. So if you really want to get funky, our users have run BSD jails on them. On Nomad, they've run Amazon ECS workloads. And I really am excited about this. Matt Butcher, the creator of Helm and Crestlet, is giving a talk on HashiCorp Virtual today, running Wasm on Nomad. So check that out. It's called WebAssembly and Nomad for next wave of microservices. I think that really illustrates why this flexibility matters for Nomad. And why we're really excited about it. So outside of flexibility, kind of the next major reason why we think people come to Nomad and why they're happy with it is performance. And I like to think of this in kind of two separate ways for Nomad. You can go big with Nomad performance. So Nomad's really performant at the cluster level. So we've seen in production Nomad clusters with 10,000 nodes. I've seen a Nomad cluster with a petabyte of memory running just happily along in production. That's not a petabyte of storage. That's a petabyte of memory. It's really hard to do something like that with a competing orchestrator. So that's Nomad going big. But Nomad also goes small. So Nomad's performant at the actual process level running on your VM, right? It has low CPU overhead, low memory overhead. And so you're able to stick it on a Raspberry Pi or an IoT device, and it runs happily there. So you could go big with Nomad. You could go small with Nomad. And that performance is something that's just really important to the team. And then so the next major reason why I think people come to Nomad, and what I'm going to just focus the rest of this talk on, is simplicity. And this is performance, flexibility, these things don't matter if you can't actually deploy something to production, if you can't skill people up on a tool. And so we think simplicity is really the main reason why people come to Nomad and love it. I personally feel that there's kind of a yearning out there for a simple orchestrator experience, something that gets out of the way and does its job, doesn't suck up a ton of time, and we really think Nomad is that tool. And so what do I mean by simple, though? right? Because simple can mean a lot of different things in a lot of different contexts. And I think that this is one of the things that we've kind of shifted our stance on the team. And we're focusing on a different type of simple on Nomad right now. And so simple could mean technical simplicity. So Nomad is a single binary. You don't need a PhD to understand the architecture. It's technically simple. That's nice. It's simple. It has product simplicity. We talk a lot about the Unix philosophy, do one thing, do it well. Nomad is not trying to become the API for all of your infrastructure, your whole data center. It's just trying to be a really good orchestrator. So that's nice. But I think the type of simplicity that we're focusing on more and more on the team, especially over the last year and the last release and upcoming release, is how do we make using Nomad simple? So user experience simplicity. And when this is in conflict with technical simplicity or product simplicity, we've decided that we're willing to expand the product in some ways, kind of add things onto it to make sure that this remains true. And we continue to really push on this. How do we make using Nomad simple? And so what do I mean by this concretely, right? This is kind of abstract, but in terms of the actual features, things that are changing in Nomad, what do I mean by simplicity? And I want to illustrate this with a Nomad story. And so over the next 10 minutes or so, follow a hypothetical company. And it's going to go from just being someone's side project that they work on the weekends to being a startup to being an enterprise company. And we'll see that by using Nomad, and especially some of the new changes that we've added to Nomad, they're able to have a really simple architecture throughout, right? So for each stage of their company, they only have to get as complex as they need, and their team can stay small, agile, and focus on what they care about. All right, so that's the Nomad story. Let's get into it. So we start off this company as just a side project. And like a lot of great companies, it's just going to exist to scratch our own itch, solve a problem that we have. And so what's that problem? Well, we keep missing the bus, right? We just moved to Amsterdam. We're not used to good public transit. And 8:30 rolls around. It's time to go down to get the bus. And we miss it again. And so, hey, we're technologists. We can solve this with computers, right? Computers to the rescue. So we decide, hey, we're going to take a Raspberry Pi, hook it up to an LED light, and it's going to flash that light at us when it's time to go down to get the bus. So we won't be late for work anymore. So that's our idea. And we don't want to waste that much time on this. We don't want to over-architect. So how do we integrate this into our daily life? So we're going to say that we just have a really, really simple architecture. And that architecture is we have a Linux box that we stuck in our closet somewhere, right? It's just a computer tower running Linux at home, right? Doesn't get any simpler than that, just a home server. And what's really nice is you could run Nomad on this just fine, right? And so what would this look like with Nomad? You run a Nomad agent as both a server, which is the control plane, and a client, which is the data plane. And you keep that on the same agent running in Nomad. And then you run a bunch of Nomad tasks, right? So since this is a home server, it might be a Plex server or Pi-hole or Nextcloud, something like that. And you're running all that locally. And this is really easy to configure. So my configuration for just Nomad on a single box, I enable server, I enable client, and then I give it this bootstrap expect equals 1, which essentially says, hey, this isn't a big cluster of compute. It's just one little computer running Nomad. And that's a great way to start, right? A lot of people are running this at home, just kind of messing around on a home lab or a home server. So check that out if you're a hobbyist. It's really fun. But now it's time to add this Raspberry Pi, right? So we have this device that we need to run some workload on. So we add that to our architecture, right? And that's going to be sitting in our kitchen. And so we run a Nomad agent on that. And that's just running Nomad in client mode. And then it runs a couple of Nomad tasks. So one might be, hey, download the bus schedule from some API. And another one is, a small Docker container to turn this light on and off. Really simple. And it works for us, right? So we get that deployed. We don't have to waste that much time figuring out the orchestrator because Nomad's relatively simple. And it works out. We never miss the bus again. We're always there on time for work. And slowly what we realize is people start coming over to our house and they say, hey, what's that light in your kitchen? Like, I would love one. I'm always missing the bus too. I'm always missing the train. And we find out that this is a massive problem in Amsterdam. All these people are missing the bus and train, and we think, hey, this is the next billion-euro startup idea. We're going to make a company out of this. So what's going to happen now is our architecture has to adapt, and it has to grow a little bit. But we still want to keep it pretty simple. We don't want to sink tons of time into a ton of new tooling and changes when we don't have to, right? This is a small startup, just a couple people maybe. So what does our architecture look like? So you could just take that server that was in your closet, stick it on the cloud, and just run a single machine. Some people do that if they're super cost conscious. We'll go a little bit more advanced for us. So what we're doing is we split out the Nomad servers from the Nomad clients. So the servers, again, control what gets run where. And we'll do a high availability cluster of those. And then the Nomad clients, which actually run the work, we'll just stick in an auto-scaling group. And this is all just running Nomad at this point, right? So it's sitting in some cloud region, running Nomad happily. And so that works. That's a pretty standard scheduler architecture. But now we have all these edge devices that need to be connected to Nomad in some way, right? There are all these Raspberry Pis all across Amsterdam, and we need to connect those to our server cluster. And what's nice with Nomad is this doesn't get that much more complex. We just run a bunch of edge devices running a Nomad client, connect them to our server cluster. And what's nice is that this is a single cluster, right? This isn't a cluster of clusters. I'm not running all these clusters on the edge. It's just single Raspberry Pis connected to our server cluster running Nomad. And that's pretty simple. And what's nice is this has gotten easier since Nomad 1.3. So this is one of the changes that keeps this architecture simple. As we added this max client disconnect value, which essentially allows Nomad to say that if a client loses connection, has high latency, as long as it comes back within this period, Nomad will just gracefully accept it back into the cluster. So this is really nice for edge devices, for IoT. It's even really nice if you say you want to run your main cluster in US East 1, but also have client workloads in Europe. And you just keep that all in a single cluster, keep a really simple architecture that way. So for edge stuff, it's a really fun use case. More and more people are doing it with Nomad. I want to just give a shout out. James Rosell is giving a talk later today how Nomad 1.3 enables running work on the edge. Check that out. It's a really fun demo. And then if you want to ever run a cluster of clusters on the edge, our friends at Portainer wrote a really cool integration running up to thousands and thousands of Nomad clusters for edge workloads. So check that out too. If you just Google Portainer Nomad, you could find it. All right, so that's our architecture and how we have a single cluster, things running both in the cloud and on the edge. But how do our services communicate now, right? How do we do service discovery? And I think a year ago, our answer to this would have been Consul, right? And we would have said, hey, just set up Consul. That works, right? Consul's a best-in-class service mesh. But we kept getting feedback from users that was saying, hey, I know service mesh is great. I know I want to be there eventually. But I don't need to be there now. I just have service A. It needs to talk to service B. Just give me an address and port. I'll figure out the rest. Make it as simple as possible. And so we took that advice, or we took that feedback, and we delivered recently native service discovery built right into Nomad. And so now you don't have to necessarily use another tool if you don't want to do simple service discovery. And we delivered that in 1.3. People were really happy about it. And we have a bunch of improvements coming in 1.4 and subsequent 1.3 releases. So I'll go through those right now. So the first of which is just a UI coming to Nomad to track all of your services. So these could be Nomad services or Consul services all in one place. And this gives you a really clear view of what is exposed in your cluster for east-west traffic. And really quickly, what does it look like to actually enable something on Nomad for service discovery, right? So I run a job on Nomad. I just add this service block. I give it a name. This is the billing service. I expose a port, the API port, and I say that Nomad is now the provider for this service. And now other apps, other microservices can ping this really easily within my cluster. That's it, right? So if you're on Nomad, you get a job running, and service discovery is essentially done. And another thing that we added, or we're about to add, is native health checks coming right into Nomad. So this is very similar to Consul health checks, a lot of people said, hey, the service discovery stuff in 1.3 is fun, but I can't put it into production until this is in Nomad. And so we're adding this into Nomad in 1.4. These are HTTP or TCP health checks, again, built right in Nomad. Just like you would configure a Consul health check running on Consul, you could do the same thing on the Nomad side as well without having to set up that extra architecture until you need it. So that's native health checks and basic service discovery. But there's this question, which is, how do we load balance within this cluster, right? So we're a startup now, right? We're actually running stuff in prod. We probably don't have just one instance of service A talking to one instance of service B. We want some sort of load balancing, given that this is a real company now. And the standard story looks something like this, right? We have a bunch of instances of A. They talk to some proxy that fans out requests to service B. And this generally works, right? And you could set this up right now. You could drop in Traefik there. You could drop in HA proxy. You could drop in Nginx and configure that. That's fine, right? That works. But it has a couple downsides. One of which is just the latency. That's a small amount of downside there. But the biggest thing is just the overhead of having to learn this, pick the right tool for the job, figure out how to manage it, when all you might need in this scenario is just super simple load balancing, right? You just want to essentially randomly pick from this list and do round-robin DNS equivalent, something like that. So what I'm excited about is, for very simple use case for load balancing, we could just have Nomad do this, right? It knows where all the instances are, so we could just have it configure instances to talk to the other right instance without having to jump through some proxy. And so we do this with rendezvous hashing, or highest random weight hashing, it's called. And it's really, really simple to set up. So if you want load balancing in your Nomad cluster, all you have to do is something like this. When I'm configuring some file, say this is a TOML file that configures where my database is, I say, hey, I want one Nomad service using the new Nomad service keyword. I say I want the billing service. And then I give it an allocation ID, which essentially says I want a different randomized service for every allocation, right? So every allocation will talk to a different instance of the billing service. And that's how you set up load balancing, right? It's just a couple lines of code. You don't have to mess with something else. If you have a simple setup, if you don't want to waste a bunch of time, configuring whatever, you can have load balancing just like right out the box with Nomad. And then, of course, when it's time to get advanced load balancing strategies, you just drop a proxy in. And that's a simple way to eventually upgrade from there. All right, so that's east-west traffic. And now we have this question of, how do we do north-south traffic, right? Like, how do we do ingress into Nomad in a simple way? So that usually looks something like this, right? We have some external request. We have something sitting on some exposed port. And then it fans out requests to nodes as we see fit. And with Nomad, I'm really excited to share that coming in Traefik 2.8 is native Nomad support. And so all you have to do, run Traefik as a Nomad job, and then add a little bit of configuration to each of your Nomad services when you define them, and you automatically get ingress running. Really, really simple way to get north-south traffic running in Nomad. So what does this look like? How would I actually deploy this? So first, I have to run a Traefik job. In this case, I'm using Nomad Pack, which is our package manager and templating tool. And I say, hey, just give me the Traefik ingress job, throw that up onto Nomad. So now that's up and running. And then in my services, I just add tags or metadata. And now this is automatically exposed to Traefik, right? So I've enabled this billing service to be routable to the outside world as long as I just hit the billing path. And instead of trying to spend a lot of time figuring out ingress, you could just run a single command to get the job running, add 4 lines of code, and now you have north-south traffic. All right, so our final challenge now that we're a real startup, is how do we manage secrets, right? That's going to be a challenge. We can no longer just hard code stuff on our server in our closet. We have to really think about this now that we're handling real money. And kind of like the story with service discovery, a year ago we would have said something different. A year ago we would have said, hey, use Vault. It's a best-in-class secrets management tool. But we got feedback from our users that were saying, hey, I don't want to set up Vault yet, right? I know that I want to get there eventually, but just for the first year of my company, I don't have that many requirements, right? I just have, hey, let's 5 static secrets, 10 static secrets. I just need a place to put them that's safe, right? And so for that type of user, I'm really happy to announce that coming in Nomad 1.4 is something we're calling secure variables. And so secure variables are essentially an encrypted key value store built right into Nomad, so you don't have to deploy anything else. They're encrypted at rest with AES 256 encryption, encrypted in transit with Nomad MTLS, and protected by our ACL system. And so this allows a very easy way to do secrets management, configuration management built right into Nomad. You don't need to use another tool until you have to. And so what does this look like in practice? So I could set values in the Nomad UI. I could, of course, use the API, or I could use the CLI. Really simple. I just put something to the keys billing path. This is putting, getting, and destroying from the CLI. And then when it's time to use that secret, say I'm writing a file with it, I just use this new Nomad variable keyword, grab the secret, plop it into a file if I want. Really, really easy way to start using secrets in a secure way with Nomad without having to do anything except use Nomad. Great, so that's startup mode, right? And so this is a success, right? Since we didn't have to waste time dealing with our orchestrator, we focused on our business. Tons of people, bought this and they love it. They start telling their friends. They start telling their friends. Turned out everyone was missing the bus, and now they're not missing the bus anymore, right? GDP is up 5%. Huge, huge success. Time to scale the startup. And as we scale the startup, there are going to be challenges that arise, and our architecture is going to have to get more complex, right? Kind of the simple version of what we deployed initially is going to have to evolve. Because we're using Nomad, it could evolve naturally and gradually as we see fit. So some of the challenges that arise might be something like this. Hey, how do I onboard new users to Nomad? I had an SRE team of 2 people. Now it's 10 people. It's going to be 15 people. And our story for this before was that you have to kind of manage ACL tokens yourself, right? You have to issue the tokens. You have to revoke them, et cetera, swap them out. And this was a lot of toil that we put on the developer. It wasn't a simple experience. And so for this, I'm excited to announce that coming in Nomad 1.4 is single sign-on built right into Nomad. And this is available in open source Nomad, not enterprise Nomad. And so this allows you to configure something like Okta, Auth0, any OIDC provider, Amazon Cognito, and of course, Vault is an OIDC provider as well. You could sign on with one of those and then get your ACL token automatically issued, and then eventually revoked if you change something in the OIDC provider. Really simple way to do auth. If you're used to the Consul integration, it works a lot like that. So that's coming in Nomad 1.4. And then there's also this question of, hey, how do we scale service discovery? So whereas before we said, I just need service A to talk to service B, eventually you're going to need more than that. You're going to want something like a full service mesh. You want MTLS, traffic shaping, intentions, observability. Well, luckily, HashiCorp makes best-in-class service mesh. So what can we do there? How do we actually jump to Consul? So we get Consul up and running. We get the Consul servers up, and we stick a Consul agent on each client alongside our Nomad agent. And then when it's time to rewrite our jobs, we just do this. We remove provider equals Nomad, and we swap it out with provider equals Consul. And now, instead of the services being defined in Nomad, they're automatically added to Consul, and we start using that for service discovery. So a really simple way to gradually adopt Consul when you need it. And then there's this analogous question of, hey, how do we scale secrets management? All right, we had 10 static keys. That worked for a while. Now we want dynamic secrets, and we want all the other goodies that Vault gives us. Similar story, right? We spin up Vault. We optionally put a Vault agent on the client. And then when we're writing our files or grabbing these secrets, we swap that out. So instead of using the Nomad variable keyword, we use the secret keyword to grab a secret from Vault. And again, you don't have to rewrite the world to get onto Vault now. You're just using Nomad. And when it's time to graduate, you can do that. All right, and then eventually our company becomes a big enterprise company. And I won't spend too much time here, but there are several other features that have been in Nomad that are really good to adopt at this point. So even though Nomad scales really well, eventually you'll want to shard it, right? And for that, we have multi-region federation, a way to connect clusters to each other. So you still have this single pane of glass, even though it's multiple Nomad regions. We have Nomad Pack, so if you ever want to standardize the way you do jobs in Nomad, you could use our templating tool and package manager to say, hey, this is how we deploy a load balancer here. This is how we deploy a Docker job. Standardize that process in your team. And then we have Quotas in Nomad Enterprise, which essentially says, hey, this business unit only has access to this much CPU, this much memory. You can restrict people that way. So once you're an enterprise company, you have all these features as well. And so just to kind of look back, is that I think these features that we added recently and that are coming soon really allow for simplicity at any scale, right? If you're just hacking away on Nomad on your weekends on some side project on a home lab, you can run Nomad in that scenario, right? If you're a small startup with a small team and you only want the simplest possible infrastructure, you can run Nomad at that scale. Or if you're a large enterprise, you can run Nomad as complex as you want. And your complexity scales only as much as you need it to be. So we think that that's really exciting. And so just to recap, so out now in 1.3 or coming soon in a 1.3.x release, native service discovery, edge client support, simplified load balancing, and the Nomad Traefik provider. So that's all out or coming soon. And then coming in Nomad 1.4, which we're targeting a beta for August, is secure variables for secrets management, single sign-on, native health checks, and a service discovery UI. And so I'll leave you with this. I really think there's been no better time to try Nomad. I personally think that there's a yearning out there for something simpler, a scheduler that gets out of your way, that's easy to use at any scale. And I think Nomad is that scheduler. So if you're interested, please talk to me after this, or kick the tires on Nomad, give it a shot. We're excited about it. Thanks. Have a good HashiConf.